Welcome! Let's take a look at evaluating the limit as x approaches infinity of x raised to the 1 over natural log of x power. As x approaches infinity, what happens to our base? Well, as x approaches infinity, the base will approach infinity as well. Now, in the exponent, as x approaches infinity, the denominator of the exponent will approach infinity, and therefore the entire exponent will approach 0. So we have an indeterminate form of infinity to the 0 power. And so what we need to do to resolve this indeterminate form within the limit is to rewrite this so that we end up with an indeterminate form that is either 0 over 0 or infinity over infinity. So we will need a strategy to move part of this indeterminate form, more specifically this exponent, out of an exponent. So let's go ahead and focus on how we can rewrite this function in an equivalent form. So our function y is going to be x to the 1 over natural log of x power. Let's go ahead and take the natural log of y, or the natural log of both sides of this equation. So we have the natural log of y is equal to the natural log of x to the 1 over natural log of x power. Now, using properties of exponents, this exponent of 1 over natural log of x can become a factor. So we could have the natural log of y is equal to 1 over the natural log of x times the natural log of x. Now notice that as we did that, we have, in essence, 1 over the natural log of x times the natural log of x over 1, which simplifies to the natural log of y equals 1. In this form, notice that we have resolved any indeterminate issues and have actually arrived at a constant 1. Now recall that we're interested in the limit as x approaches infinity. So the limit as x approaches infinity of the natural log of y is equal to the limit as x approaches infinity of 1. Well, the limit as x approaches infinity of the natural log of y, well, the limit as x approaches infinity of 1 is simply 1. So this is equal to 1. So we know that the limit as x approaches infinity of the natural log of y is equal to 1. But the limit we were originally asked about is not about the natural log of y, it's about y itself. So let's see how we can get back to the limit for y itself. So let's think about the limit as x approaches infinity of the natural log of y. Now we noted that the natural log function is continuous, so we can say that this is equal to the natural log of the limit as x approaches infinity of y. Now, we previously found that this limit of the natural log of y, we know that that is equal to 1. So that means that 1 is equal to the natural log of the limit as x approaches infinity of y. And what we want is we want to know what this limit, the limit as x approaches infinity of y, is. So we can either exponentiate both sides of the equation, or you can just simply rewrite this in a logarithmic equation in exponential form. I'll go ahead and think of exponentiating both sides of the equation. So e to the first power is equal to e to the natural log of the limit as x approaches infinity of y. And so what that ends up giving us is e on the left-hand side of the equation. And now because the exponential function and the logarithmic function, base e, are inverse functions, the right-hand side of my equation simply is the limit as x approaches infinity of y. Now, keeping in mind that y is our original function, we can say then that the limit as x approaches infinity of x to the natural log, to the 1 over natural log of x, is equal to e. I hope you find this helpful.